Hello again, and welcome back. If this is not your first time, jumping in today, looking at some factors and multiples. What should be a review. It's some things that I've noticed in the past that my students have struggled with, just knowing vocabulary. But always good to have in mind. This is something that comes up in a lot of other different skills. As always, the YouTube channel and the email address up at the top in blue. But just as a reminder of what factors and multiples are. Factors, again, are just the numbers you use to multiply to get another number. Multiples are evenly divisible by those factors. So I'm only looking at integer factors just to keep things simple. That's typically what you're going to need to know. Again, factors are what's used to multiply to get another number. And multiples are the results of multiplying a certain number. And essentially, if you're asked for the multiples of a certain number, you can act like you're counting by that number. Those are all the multiples. In this example down here, 3 times 4 equals 12. 3 and 4 are both factors, and 12 is a multiple of both 3 and 4. So 3 and 4 are the factors in this case, like I said, the factors of 12. Those aren't the only factors of 12. They're just the factors in this context that we're seeing right here. So, you may see them as in a written equation like this. If we were sticking with the number 12, if we were wanting to list out all the factors, I've done so, and then I've also done a list of multiples. So factors, again, any numbers that can be used to multiply to give another number. So those are all the integer factors of 12 right there, because you can multiply any of those by another number to get 12. So 1, 2, 3, 4, 6, and 12. And if you'll notice, 1 times 12 gives you 12. 2 times 6 gives you 12. 3 times 4 gives you 12. So, I didn't pair them up, but those are the numbers that, again, multiply to give you 12. And then if you want to know some multiples of 12, again, act like you're counting by that number, repeatedly adding that number, whatever you want to say, or essentially multiplying that number by 1, then by 2, then by 3, then by 4, etc., etc., etc. There's an infinite number of multiples of any number, so I'm not going to list all of them out for obvious reasons because we'd be here forever. But these are the multiples of 12, or the first few multiples of 12 right here. Again, 12 times 1, 12 times 2, 12 times 3, and so on. So 12, 24, 36, 48, 60, 72. So again, factors are the pieces. Multiples are when you expand it out, when you multiply it. Now, why do we need to know this? Well, because in a lot of different, skills that you're going to learn, you're going to need to know common factors. You're going to use common factors or common multiples to be able to move along the process. One thing that we're going to see a lot of is the greatest common factor, or at least common factors. But if you can figure out the greatest common factor, that's the best move. But the greatest common factor is often abbreviated as the GCF. It is the largest factor that 2 or more numbers share. So it's just like it sounds, the greatest common factor, if you think about what the meanings of all those words are. So how do we find the greatest common factor between 2 or more numbers? I'll just start with 2. This can be kind of, again, extrapolated out to if you're finding the greatest common factor of multiple numbers, kind of the same way. So I want to find the GCF, the greatest common factor, of 16 and 36. So I can do this in one of two ways. And this is where the divisibility rules come in handy. If I know quickly what number will divide evenly into another, in other words, if I can figure out the factors, it's going to go a lot quicker. But I always start with 1 in the number, and I make them into pairs. So 16 will divide evenly by 1 and 16. You could also think of this as what times what gives me this number. However you want to think of it in terms of division or multiplication. 16 divided by 1 is 16. Will 16 divide evenly by 2? Yes, it will. 2 times 8 gives me 16. Will it divide evenly by 3? No, it will not. If you remember your divisibility rules, you can add the digits and see if that number divides by 3, and it doesn't. So 1 plus 6 is 7. 7 does not divide evenly by 3. So moving on, I'm just going in number order, 1, 2, 3, 4. And then 4 times 4 will give me 16. And if I ever double up, or if I write down a number that I've already written down, I know I'm done. I've listed as many factors as there possibly could be. And in this kind of U shape from left to right, those are all my factors in order of least to greatest. So those are all the factors of 16 right there. You really you can scratch out the 4 if you want to, just because it's a double. But I'll leave it there just because. And then 36, we can do the same thing. All right. Well, 1 times itself is always going to start us off. Will it divide by 2? Yes, it will. Will it divide by 3? Well, 3 plus 6 is 9. That will divide evenly by 3. So that's going to be 3 times 12. Obviously, you notice the numbers on the left are getting larger. Numbers on the right are getting smaller as we go down until hopefully they meet or they cross. I know that 4 times 9 is 36. I know it will not divide by 5. And I know 36 will divide by 6. 6 times 6. Another double, just a coincidence here. I picked 2 perfect squares in 16 and 36. It's not always going to be that way. But those are the complete set of factors of 16 and of 36 right here and right here. And so all we have to do now is look and figure out what is the greatest common factor of 16 and 36. What is the largest number that they both share? So I'm going to start from the largest of these factors of each number and work my way down. So I'll start with 16. Does 16 also divide evenly into 36? I'm looking at the other list. No, it does not, so that's out. How about 8? Well, I'm looking over here. There's no 8, so that's out. What about 4? Well, I find it on the other list. So 4 is the greatest common factor of 16 and 36. Now, if you want to think of this logically, if I'm looking for the greatest common factor of 2 numbers, it can't be any larger than the smaller number because we're talking about integers here. It can only be as high as 16 because if I multiply anything by a number, any integer by a number higher than 16, I'm getting a number higher than 16. So it's not going to work anyway. So if you wanted to find the greatest common factor of 2 numbers, all you have to really do is look at the smallest of the numbers. Whoa, I don't know what I just did there or what OneNote's doing, but you can actually just pick the smaller of the 2 numbers and just ask yourself, all right, let's start this over. You can just ask yourself, all right, well, will 16 divide evenly into 36? And that's all you got to do. And the answer is no, so move on. How about 8? Nope. How about 4? Yes. Okay, so you don't need to list out all of the factors of both numbers or of all the numbers, just the smallest one. Okay, so if you like to list them all out, great. If you don't want to, even better. Again, find the GCF of 4 and 12. So again, we can just list out all the factors of the smallest number, in this case 4. That's pretty simple. 1 times 4, 2 times 2. Again, I picked a perfect square, so just the way it went. And then we can say, all right, well, which one of these? What's the largest of these numbers that will divide evenly into 12? And some of you have already been yelling at your screen for a couple of seconds. Just 4. 4 will divide evenly into 12. Notice, sometimes, and it just so happened to be 4 and 4. Again, I wasn't thinking about all that stuff when I put these together. But if one of the numbers is a factor of the other number, you don't even have to do this whole process. You just know it's 4. Sometimes you get easy ones. Just for the fun of it, I'm going to list out the factors of 12 just to show you what I'm talking about. So 1, 2, 3 times 4. If I've already written down 4, there's no reason for me to do it again because I'm just going to get a repeat of 3 times 4, 4 times 3. There's no sense in doing that. That's what I was kind of talking about earlier. Once I hit a number that I've already written down, I don't need to write it down again because I'm just going to get a repeat. So there we go. And as we can see, 4 is also a factor of 12. Okay, so just a quick trick on figuring those out. So sometimes you get the shortcuts, sometimes you don't. So that's finding the greatest common factor, again, of integers. We'll deal with more of this when we talk about, polynomials as well. Finding the greatest common factor of polynomial terms, so with variables with exponents. But it's the same idea. Now moving on to least common multiple. This is the last part of our video right here. It's the smallest multiple that 2 or more numbers share. Okay, so instead of the greatest common factor being the largest factor, this is the smallest multiple that 2 or more numbers share. And so again, why do we need to know this? Well, the least common multiple, lowest common multiple, I guess either one of those works, is often used when we are dealing with fractions. When we are adding, subtracting fractions, we have to make sure for example, 1/2 and 1/3, I can't add these if the denominators are different. So I need to make sure I'm able to multiply each of these by some form of 1 to where the denominators are the same. And we'll do a video on that very shortly. But we want to find the lowest common multiple of those denominators to where we know we can have a common denominator. So the least common multiple is the smallest multiple that 2 or more numbers will share. So remember, multiples are just like we're counting by these numbers, or multiplying them, 6 times 1, 6 times 2, 6 times 3, 6 times 4, as I'm looking at the first example we have right here. Okay, so find the lowest common multiple of 6 and 8. Okay, we don't need to break these numbers down and see what they divide by. We want to multiply them out now, least common multiple. So my trick here is just take these numbers. This is how I like to do it, and start multiplying them by 1, 2, 3, 4, 5. You can just do a handful to start off and see if there's anything in common, and if there's not, you keep going. I like to do the smallest one first, just because it makes the most sense to me. 6 times 1, 6 times 2, 6 times 3, 6 times 4. I'm just going to start with 4 for right now. And I'll do the same thing with 8. 8 times 1, 8 times 2, 8 times 3, 8 times 4. So I've done, a few of each. There's no minimum you have to go to. If you find a common one, you're good. But I just started with 4. So we want to find the lowest common multiple. And if you don't see it already or didn't know it off the top of your head, then the way you would do this, just look through the lists. And again, instead of starting with the greatest number, like the greatest common factor, we want the lowest common multiple. So I start with the smallest number on either one of your lists. Honestly, I like going with the smallest number though. So we'll start with 6. So is 6 on the other list? Nope. Is 12 on the other list? Nope. Is 18 on the other list? Nope. I'm scrolling through. Is 24 on the other list? And there we go. 24 is the lowest common multiple of 6 and 8. There are other common multiples. And again, when you're dealing with fractions, as long as you get a common denominator, it doesn't have to be the lowest common denominator, but you're just going to create more work for yourself when it comes to reducing those fractions. So it doesn't really matter. You're going to get the same answer if you do everything right. But again, if you want the least amount of work, we want to find the least common multiple. And so one last example here, find the least common multiple of 7 and 21. Some of you might already see a pattern here, but I'm going to go ahead and knock a couple of these out. We'll just go 3 or 4, 7, 14, 21, 28. And with a larger number, you probably don't have to do as many. 21 is obviously much larger than 7. So 21, 42, 63, blah, 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 blah. Same idea. If you want to keep going, 84. But some of you might have noticed 21 is the lowest common multiple. It's the first multiple of 21, obviously because it's itself. And this is the same kind of quick trick as with the greatest common factor. If one number is a factor of the other, then that smallest number is the greatest common factor. Similar here, if one is a factor of the other or one is a multiple of the other, it's the same thing. One's the factor, one's the multiple. Then again, the largest number is going to be the least common multiple. Okay, because it can't go any lower than 21, because again, the multiples of 21 begin with 21, so it can't go any lower than that. So once you kind of wrap your mind around that, it's a nice little shortcut. If you notice patterns, which again in mathematics is a great quality to be able to have, recognizing patterns. So again, if one's a factor of the other, one's a multiple of the other, you've got a shortcut there. Again, hopefully that helps. Next time, I believe we're going to be incorporating this into the next video I'm putting out. So again, let me know if you have any kind of follow-ups, anything you'd like me to expand on. And again, hopefully that helps.